Good afternoon, scholars. This is Mr. Lowe. This is your audio recording for lesson number 2 of e-learning. Today we're going to look at lesson 4.2, which is solving a matrix equation. So this is the very beginnings of actually solving equations as it relates to a matrix. So first section was performing the basic operations, adding, subtracting, and scalar multiplication. But now we're going to extend it to solve out an actual equation. So if you notice, based off of what you see on the screen, solving a matrix equation can take on 2 forms. Either you're missing part of the matrix, as you can see on the left-hand side, or you're missing a whole matrix, and you got to find out all the parts of it. So you could be missing bits and pieces, or you could be missing the whole thing. Regardless of which type you have, how you go about solving it is the exact same thing. You're still matching up part to part. You're still matching up corresponding parts and then using it to solve out the actual problem. So in some cases, the problem may be shorter or longer depending on what you have to get solved. So we're going to start with finding missing parts. Remember, the objective is match up everything and then solve what you need to find. Now, if you're just missing parts, then you only have to worry about the parts of the matrix that had a variable in it. For example, in example 1, you're trying to find out what is x and what is y. But look at where x and y are located. So since x is located there in the first matrix, you only have to worry about its corresponding part in the second matrix. And those will be the parts that you match up. 2y is in the bottom left-hand corner, so you only have to worry about the bottom left-hand corner. So again, you're just matching up part to part. So this leaves you with 3x equals negative 18. So x would equal negative 6 when you divide both sides by 3. And then negative 4 equals 2y, which divide by 2, you get negative 2 equals y. And that's it. It's solved out and you're done. So again, you're literally just matching up part to part and then solving it out from there. Now, if you look at example 2 is a little bit different because now you have, well, 1, it's a longer problem, and 2, you have a scalar being multiplied by another matrix. So what you want to do first is take that 2 and multiply it into the matrix to make it a little bit simpler for yourself. So the first matrix we'll leave completely alone. The second matrix, everything times 2 would give you 10, negative 2, negative 14, and 12. And then negative 9, negative 13, 4, and y. Now, once you've done that, you go back to the original protocol, which is matching up all the parts. So negative 2x, top left-hand corner, so matches up with the 10 and the negative 9. Negative 2x plus 10 equals negative 9. The y is in the bottom right, so bottom right, bottom right. Negative 8 plus 12 equals y. And then we just go about solving it out. So to get x by itself, subtract 10 on both sides, so negative 2x equals negative 19. Divide by negative 2, so x equals positive 19 over 2, or 9.5. Yes, you can get decimal answers for these too. Decimals are numbers. For the y part, that for the most part is pretty simple. Negative 8 plus 12, 4. Negative 8 plus 12 is 4. So you're all set and ready to go there. So that takes care of example number 2. So example 3, I'll leave for you to try yourself and to literally see how far you can get with it. However, to make sure that you have something to work off of, if you do it correctly, so we'll set up the answer for you just so that way you have it. So if you were to solve that one out correctly, you should, if I can find my answer key, you should get answers of x equals 5 over 2 or 2.5 and y equal to 1 if you do example 3 correctly. Again, feel free to email me if you have a question with regards to it. So that's just finding parts. Now we're going to solve for a whole matrix. So now we're going to solve for a whole matrix. So when you're solving for a whole matrix, it will help you to put a placeholders for that matrix. So for example 4, where it says x, you need to look at what the other matrices were so that you can create a placeholder. So notice that the second matrix was 2 rows, 2 columns, 2 by 2. 2 rows, 2 columns, 2 by 2. So you need to create a placeholder that's 2 by 2. Blank, 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 blank. So 2 rows, 2 columns. So 2 rows and 2 columns. Now, as far as the variables go, you can literally make the variables whatever you want. So I'm going to use A, B, C, and D. But again, feel free to make them whatever you want. Now you set up each of the equations and you start solving out each of the equations. So A goes with -5, goes with 7. So A plus -5 equals 7. A positive and a negative would become negative. So A equals 12. So there's 1. B, 0, -8. So B plus 0 equals -8. B equals -8. So let me not box it up because that's not how you'd give the final answer. C goes with 4, goes with -3. So C plus 4 equals -3. Subtract 4 on both sides. C equals -7. D, 3, -3 and 5. So D plus -3 equals 5. D minus 3 equals 5. So D equals 8. So now we have all 4 parts. We put them back in the matrix to give our final answer. So matrix X would equal 12, -7, -8, and 8. And that's your answer for example number 4. So it's not a harder problem. It's a little bit longer of a problem because there's a little bit more setup involved. But definitely not anything that you all can't handle. Definitely not anything that you all can't handle. Let's do example 5. So example 5, you have -x plus the second matrix equals that third matrix. So let's keep a couple things in mind with that negative x here. So negative x, remember, if there's no number in front of a variable, there's understood 1. And since there's a minus sign in front of that, this would be negative 1 times matrix x, which means negative 1 is now a scalar. So that's the same thing as negative 1 times the 4 parts that would be inside of that matrix. So again, there are small, subtle things that you have to keep in mind. And so since we have a scalar being multiplied times a matrix, we're going to multiply everything times that negative 1. So that gives you negative a, negative b, negative c, negative d. If you want to put 1s in front of them, that's fine. That's your prerogative. Anything that's going to help you solve out the problem easier. But after that, same type of problem as we just finished solving. We match up part to part. So negative a matches up with the negative 3 and matches up with the 8. So that gives you negative a minus 3 equals 8. Add 3 to both sides. Negative a equals 11. But remember, the variable can't stay negative, so you divide by negative 1. So a equals negative 11 would be that first number. Moving on, you have negative b plus 1 equals negative 9. Subtract 1, that gives you negative b equals negative 10. So b equals positive 10. On to the next one. Negative c plus 4 equals 0. Subtract 4, you get negative c equals negative 4. So c equals positive 4. And then lastly, negative d plus 7 equals 10. Subtract 7, you get negative d equals 3. Divide by negative 1, d equals negative 3. So for your x matrix, you end up with x equal to the matrix negative 11, positive 10, positive 4, and negative 3. Then, it's not a harder problem, it's just a longer problem. It's definitely not a harder problem, it's just a longer problem to solve out. So lastly, example 6 is one that I would leave for you to attempt. So here are the answers for that particular matrix. Turns out to be one that does have fractions in it. So the x matrix would become negative 2/3. I would not advise you give that as a decimal. 3, negative 17 over 3, and positive 1. So if you end up with the fractions and decimals, don't panic. You didn't do anything wrong. It's just how it ended up working itself out. So this concludes the 4.2 lesson, which is solving a matrix equation. Again, this is the basic form of solving a matrix equation. Now keep in mind, we haven't multiplied matrices yet. So as we start to multiply matrices, then we get into deeper level equations. But for right now, if you know how to do the basic, you'll be in good shape. With that being said, the next practice assignment and next IELTS will be put up for this shortly. Have a great rest of the afternoon.